Hi, in this lecture we are going to discuss again double dispatch in the case of non-symmetrical use of double dispatch. So we are going to look at double dispatch again, but we are going to see that it doesn't have to be symmetrical as we have seen in previous examples. So remember, in the previous lectures we have seen the paper, scissors, stone example where we could make stone versus paper or paper versus scissors, and so it's a paper, scissors, rock game, and then the result was the one that win. Yeah. Now the problem with this is that it could lead you to the confusion that always having a double dispatch requires to have a symmetrical implementation. So here actually in stone we had to implement the versus scissors, versus stone, and versus paper. And we had to do actually the same in the paper, for example. So we had to implement each of the versus methods in each of the classes. So that is not actually always the case. To put you in context, let's imagine a game model of a Sokoban. A Sokoban is a game where we have a little person that is going to push boxes in a maze, and the objective of the game is to put each box on top of each of these dots. Yeah, so we have in our model we have boxes that are above a target, so like this one. We have empty blocks, which represents the empty square where we are going to be able to walk. We have player, we have walls that we can trespass. Let's imagine an implementation that actually it is implemented with too many ifs. What is happening here is that here we have a block. Here, this block is a block in the game. So here, for example, this could be a box, it could be a player, it could be a wall. And then here what we are doing is trying to draw it. So to implement that, what is happening here is that we are taking the block and we are asking, are you a wall? Then I will draw a wall. Are you a player? Then I'm going to draw a player, and so on. If we wanted to implement this using double dispatch, one other way to implement it is to directly delegate to the block object. So instead of asking the block what it is and then deciding ourselves how to draw it, what we can say is, okay, block, you know who you are, so draw yourself on this canvas, and I am the view. And then each kind of block, for example, the wall or the empty blocks, they can tell the view, okay, draw a wall or draw an empty block in this canvas. Yeah. So here, what is happening is that to be able to draw something, we are doing a double dispatch. The decision to draw, it is shared between the game view that knows how to draw different elements, like drawing a wall or drawing an empty block, and the block itself that actually knows how to dispatch to the view. What this solution helps us to do is to, for example, change and have different kind of canvases and views to be able to draw. So we are doing double dispatch between the different kind of blocks. So we have the block hierarchy, block 1, block 2, block 3, and then we are going to have canvases or views, and we are going to be able to have different kind of canvases to draw differently. So for example, here we could have an HTML view that will draw in one way, and we could have, for example, a vectorized or a 3D canvas that will draw it in a different way. So what is happening here is that we're telling the view how to draw an element, and before that we are telling the block that it has to draw itself, because the only one that knows how to draw itself, what kind of element it is, it's the element itself. So we are telling the element, draw yourself, and then the element will tell the canvas or the view, oh, I am a block, draw myself. So in this way we can have a really modular system where we can change the canvases, add new kind of blocks without rewriting the entire system. So that is why sending messages is a powerful tool. What happened here is that what I told you, actually the double dispatch doesn't need to be symmetrical. What happens is that you need to look at the double dispatch like a matrix. So in this case, for example, we have all the different kind of blocks. We have walls, we have empty blocks, we have players, and then we have all the different canvases. Canvas 1, HTML, 3D. So, in the previous case, when we had rock, paper, scissors, we had rock, paper, scissors here, and we had also rock, paper, scissors in there. That's why we had a symmetrical model. But in this case, what we're crossing is the different blocks and the different canvases. So in this case, our model and our double dispatch is not symmetrical. In conclusion, double dispatch is a good way to add a variation point without hard-coding all the entire path of execution. It is modular because we can add new elements in the decision process by adding, for example, in our case, new canvases or new blocks. And it can be symmetrical, as in the case of the rock, paper, scissors, or it can be asymmetrical, like in this case here.